right, here we go. 3.1, periodics.
A periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. The period of a periodic function is the length of the x values that is taken for the function to complete one cycle.
All right, so again, it's a cycle. Okay, it happens depends on what we're talking about. All right, example 1. Here we go.
The function's f is periodic with period 4. A portion of the graph is f is shown above. Draw 2 additional periods for the graph of f on the axis above.
So on this one, it says it has a period of 4. So a period is a cycle that happens over and over. So do you see how it's kind of happening over and over from -1 to 3 and then 3 to 7 and so forth? All right, you see how it's a gap of 4 for my x values? And so we're just going to draw 2 more periods on this one. So we're going to just sketch. So that would be 1 more period. And then we're going to do it again. And then that would be 2 more periods. All right, cool. All right, example 2.
A portion of the graph of the periodic function g is shown above. What is the least possible value of the period of g?
All right, so let's look at this one. So we have this, and I'm looking at these kind of points right here. And so when will it complete its cycle? In what? 5, right? Because it goes from 1 to 6 and it completes its cycle. All right, and so the period on this one is 5. All right. All right, so example 3 now. And so we're going to use that function to find the following values. So I need to find g of 14. Well, does the graph go for my x value to be 14? No, it doesn't, so we can't do this one, right? Just kidding. We're going to use our periods. And so we're going to go back a period. And so g of 14 is the same thing as g of 9 because I'm using my period of 5. And g of 9 is the same thing as g of 4. And so all of those should be the same because I have a period of 5. It's a cycle. It keeps on happening. And so what is g of 4 or g of 9?
G of 9 is
7. All right, they go up to 7 right there. And so g of 14 is 7. So we used its period to figure that out. All right, so this next one, g of 72. Do I want to go out to 72? My gosh, ain't nobody got time for that. So I need to use my periods of 5. All right, and so I can keep subtracting 5 from 72. Now, what do I eventually probably want to get down to? 2. So g of 72 is the same thing as g of 2 in this case because my period is 5. And so g of 2 is equal to what? 6. So g of 2 is equal to 6. So g of 72 is also equal to 6. And we could figure that out by using its period. All right, so g of -17. Again, is this on the graph? No, so we're going to use our period. Now, I personally want to use like 4 periods on this one to find g of what?
3.
G of 3. All right, and so I'm kind of adding 20 to it. I'm using 4 periods of the 5. All right, and so g of 3 is equal to what on this one? 7. So g of -17 is 7. All right, go for it.
Example 4. The graph of h is periodic with a period of 5. The values h are shown as selected values of x. Find the following values.
All right, so this first one is h of -2. Now, is -2 in anywhere for my x values of h? No, but my period is what? 5. So if I add or subtract a multiple of 5 to -2, could I get any of these x values? Yes. So h of -2 is the same thing as saying h of what? 3. And h of 3 is equal to what? 0. So h of -2 is 0. All right. All right, let's look at the next one. So now we need to find h of 6. Well, is h of 6 on here? No, but I know my period is 5. So I need to add or subtract a multiple of 5 from 6. And so what do I want to think of? H of what?
1.
H of 1. So h of 1 is equal to what? -2. So h of 6 is -2. All right. All right, this next one is a composite. So we just got done doing composites on the last unit. And so first thing we need to find is h of what? 9. Well, is h of 9 on there? No, so I can't do it. Just kidding, we can do it. And so I need to find h of what first?
4.
H of 4. And so h of 4 is equal to 3. Now I need to find h of what? 3. Is that on there? Yeah, this one's on there actually. And so h of 3 is equal to 0. So h of 9 is 0. All right, let's look at the next one. And so this next one is h of 5k minus 3. Well, when k is an integer. So if I substitute in 1, I get 5 minus 3. And if I substitute in 2, I'd get 10 minus 3. They're all multiples of how much?
5.
5. And this is the same as my period. Okay? And so it's just going up and down a period, basically. And so this h of 5k minus 3 is the same thing as h of negative 3. And so now, is h of negative 3 on here?
No.
No. However, what could I do to find h of negative 3? I could find h of what?
7.
7. All right, I could use 2 periods, exactly. So h of 7 is h of 7 on here?
Yep.
Yes, and so h of 7 is
2.
2. And so h of 5k minus 3 is equal to 2. Because every 5, it's going to be 2 because of the period. All right? All right.
Ready?
Yep.
It is useful to have notation to model this phenomena. A periodic function starts with a basic pattern and translates the pattern repeatedly over its domain. As a result, we are able to consider a periodic function as a horizontal translation of itself.
All right, so again, it's a horizontal translation, basically, of what's happening. All right, keep going.
In example 4, the period of h was 5, meaning that we could translate the graph of h horizontally 5 units and end up with the same graph. This means that the function h satisfies the following equation for all values of x. Keep going.
Okay.
H of x equals h of x minus 5.
All right, so again, it's a shift of 5, and it will land on top of itself. All right, so whatever its period is, that's kind of what's happening when we do these. All right, example 5 now.
The graph of f is periodic with the domain of all real numbers. 2 full periods of f are shown. Find all input values of f that yield an output value of 1.
All right, so it will yield an output value of 1. So 1 is our output value down here, yes? And so what input values yield an output value of 1? 2 and 6, right? And so how often will these occur? Every how much? What would be its period? 4. So the period would be 4. And so if I need to yield an output value of 1, what x values are they going to be? It's going to be what? It starts out at 2. And then plus, what are my periods? 4 times any integer k, where k is an integer. And so this could be also like 6 plus 4k. But I just ended up with 2 plus 4k. Because every multiple of 4 now is going to add on to the 2 to give me the output value of 1. All right, pretty good. So again, it's using the period and kind of where you start on that one. All right, so this is our first task on a free response question number 3. We're going to be doing this today. We're going to do this one, and you have one on your homework. And then on tomorrow, we're going to look at a few more of these free response number 3s. Now, this is pretty much exactly the way part of your free response question is going to be on your AP exam. And so we're going to do a lot of them. And so after we do a few of them, I think you'll understand a lot more. All right, it's really not hard, but it does involve some reading and thinking a little bit. All right.
The figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At the time t equals 0 minutes, the minute hand is pointed directly up at the 12. However, the clock is not working properly, and the minute hand is moving twice as fast as it should.
Oh my.
Thus, the next time the minute hand points directly up to the 12 is at the time t equals 30 minutes. As the minute hand moves, the distance between the endpoint and the minute hand and the floor periodically decreases and increases. The periodic function h models the distance in inches between the endpoint of the minute hand from the floor and the floor as the function time in t in minutes.
All right. So let's kind of break down what was said. So how far from the ground is the center of the clock? 120 inches. How long is the clock hand? 8 inches. Okay, so everybody follow me on what this is. All right, and so the clock is moving around and around like this, yeah? However, normally it would take 60 minutes to complete its cycle, but how long is it taking now?
30 minutes.
30 minutes, all right? And so how long would it take to get to the 6? 15 minutes, right? Make sense? All right, and so how high, before I even do this other part, how high could I possibly get on my clock? 128. That would be its max, yeah? Well, what would be its minimum? 112, right? And so that's exactly what it's going to do. And it's going to do the same thing over and over, right? Because it's going to do the same thing. It's going to be its period. All right, and how long is the period? 30 minutes. Okay, pretty good? Cool. And so now what's going to be tasked for you is you're going to have this same wave. You're going to have this same wave on your AP exam. And yes, they're probably going to be labeled F, G, J, K, and P. It's kind of weird that they don't really go in order. Somewhat in order, but like not A, B, C, D, E. Okay, but I think they do that because like there's versions of A, B, C, and so forth on your actual exam. All right, so these are the letters that are going to be shown. They don't make a whole lot of sense to me, but that's what's going to be used. All right, so we need to figure out T and H of T values for F, G, J, K, and P. And we kind of talked about them, and you did very well going about it. And so F, what is going to be the T value in which F is? At time what? It starts at time what? 0. And so F is at time 0. And what is the height at time 0? 128. Is everybody following how we did that? So I'm furthest away at time 0, and it's 128 away from the floor. All right? So then I'm going to go to J, because that one makes sense to me first. All right? And so J is the lowest point. And we talked about this already. So how low is my lowest point? 112. All right? And what time is it going to be at the lowest point? At 15. It's going to be 112 for J. Do we see how we did that? And so now I'm going to go to P. And so P is going back up to the top because that's my highest point again. And so what is the highest point in which it will be at? 30 comma what?
128.
128. So this P is at 30 comma 128. Now this is where I like to fill in my other parts. All right. I always kind of like work with the highs and lows first. So this G is actually going to be at what? Is it going to be at 3 or the 9?
3.
It's going to be at the 3 because it's going from 12 and then it's going to go to 3. And so what minute value, what time value is it going to be at? 7.5. All right, because it's in between 0 and 15. And you can use fractions. You can use 15 halves. That's totally acceptable too. All right, and so 7.5 comma what? How high is it? 120. Because it's 120 from the ground. It's the same as the center. All right, and so then K would end up being what? What's my time value on K? 22.5. And then what's the Y value, or my H of T in this case? 120. And so there is how we complete our cycle. Now, this is what's called a sinusoidal curve. Okay, we'll get to it later, but I just want to kind of give a description of what it is now. It's really when you just have like a circle of a periodic thing going over and over. Okay, and so this wave is going to be the same every how many seconds? How long did it complete its cycle?
30 seconds.
30 minutes in this case. Oh, sorry, minutes. My bad. I said seconds. So in 30 minutes, it's going to complete its cycle, and it's going to do it again. All right? All right. So let's keep moving on this. Who's my reader? 10, go.
Refer to the graph of H in part A. If the t-coordinate of G is t1 and the t-coordinate of J is t2. J, on the interval t1, t2, which the following is true about H?
All right, fantastic. So, is h positive or negative? Is it a positive number or a negative number for my h of t? It's positive. All right. I have 120 and 112, right? It's above the x-axis. It's positive. Now, is it increasing or decreasing from g to j? It's decreasing. So it's positive and decreasing. All right. Pretty good. Cool. Keep going.
Describe how the rate of change of h is changing over the interval t1, t2.
All right. So this is saying the rate of change of h is changing. So it's basically a rate of a rate. Now, what's a rate of a rate? It deals with what? Concavity. All right. And so this is the way I want you to write it. And so what is h doing from g to j? H is what? I want to talk about its concavity. Is it concave up or concave down from g to j?
Concave up.
Concave up. So h is concave up. Therefore, h is changing at a rate that is what? Is it increasing or decreasing? Increasing. All right. Another way to say that is so the rate of h is increasing. All right. So there we go.